This is the second of our SOL preps, getting ready for the SOL coming up in May. Same three categories: expressions and operations, equations and inequalities, and functions and statistics. We're going to walk through these questions. Pause the video at any time if you need to go back and review a question, or if I go too fast. Number one, we're going to translate. So we've got this expression here that's expressed verbally. We want to translate it into an algebraic expression. So we're going to look here at a few different places we can start. We've got 12 less than. Less than we know is subtraction, and we're going to have to flip these. So it's going to be something minus 12. So we look on the other side, we've got the cubed root. Well, the cubed root looks like this. The cubed root of, so everything that follows goes into the cubed root. The cubed root of the product. Product means multiply. Product of x and y. So x times y, or xy, underneath the cubed root. Go back to that less than. 12 less than means we're going to subtract 12, so we end up with the cubed root of x times y minus 12. Number two, simplify. We've got a division bar. Division means that when we divide variables, we're going to subtract the exponents. So let's start with the coefficients. 15 divided by 3 simplifies to be 5 over 1. With our x's, it's a little bit off. X to the negative fifth divided by x to the second, either the top minus the bottom. So negative 5 minus 2 gives us negative 7. So we have x to the negative 7th, which means that x is going to go in the denominator. Any negative exponent, that term goes on the bottom. And then we look at our y's. We have y to the 7th divided by y to the negative 8th. So 7 minus negative 8. Minus a negative turns into adding a positive, so we get y to the 15th. That is a positive exponent, so that's going to stay on top. So remember, when you divide variables, you subtract the exponents. When you multiply variables, you add the exponents. And when you have two exponents on the same variable, you multiply those two exponents. Number three, once again, this right here is extra information. We don't need it. It's not going to affect how we solve this. So it wants it in simplest form, so we need to use the factor tree. 432, we're going to start small. It's divisible by 2, so 2 and 2, 16. Once again, keep going small. 2 16 is divisible by 2. Keep going by small numbers until we get something we're familiar with. So 2 and 54. By 2 again gives us 2 and 27. 27 is divisible by 3, so 3 and 9, and then 9 is 3 and 3. So we're looking for pairs. So I've got a pair of 2's and a second pair of 2's, and then I also have a pair of 3's with 1 3 left over. So each pair I'm going to bring outside the square root. So I've got one pair of 2's, second pair of 2's, and a pair of 3's. I've got 12 x's. So with 12 x's, I can make 6 pairs. And with 21 y's, I can make 10 pairs. And then under the square root, we still have that 1 3 left over and a y left over. So simplifying this, we've got to multiply what we've got outside. So 2 times 2 is 4. 4 times 3 gives us 12. So we have 12, x to the 6th, y to the 10th, and the square root of 3y. Moving on to number 4. Jane correctly solved a linear equation. The last line of her work was 5 equals 5. Which statement best describes the solution to the equation Jane was solving? What you should notice here is that there are no variables. When you are solving an equation and the variables cancel themselves out, and you're left with an equation with no variables, you're either going to have something that makes sense, like we do in this case, 5 is always equal to 5, or you're going to have something that doesn't make sense, like 1 is equal to 2, or negative 3 is equal to 10. If it makes sense, if it's a true equality, 5 always equals 5, then the equation has infinitely many solutions. It doesn't matter what we plug in for the variable, 5 is always going to equal 5. If you were to get something that doesn't make sense, 1 equals 2, negative 3 equals 10, Those won't ever work. So in that case, there'd be no solution. Number 5, we want to graph the solution to this inequality. In order to graph it, we want it to be in the form y equals mx plus b, which means we need to get y by itself. Notice we have 4y, so we're simply going to divide everything by 4. That gives us the y by itself. Y is greater than, let's put a 1 in front of that x, so it's greater than 1/4 x plus 3. That's in y equals form. That's in slope-intercept form. Very easy to graph. So I'm going to start at the y-intercept of 3. And then we've got a slope of 1/4. So I'm going to go up 1 and to the right 4. And I'm going to go down 1 and left 4, making sure that my points form a line with a positive slope. That means that it's going uphill. Once we have the points, because this is an inequality, we have to take into account whether it's a solid or a dotted line. No line underneath means we're going to use a dotted line. Because this is strictly greater than, it's going to be dotted. If it were greater than or equal to, you would have that line underneath, and you would draw a solid line. That's first. Now we're going to do a test point to figure out where we're going to shade. If possible, always do a test point of 0, 0. The only time you cannot do this is if the line goes through the origin, in which case you would pick a different point. 0, 0 is the easiest one to use. So I'm going to take my equation, and I'm going to plug in 0 for y, 0 for x, and simplify. 0 times 1/4 is 0. So we get 0 greater than 3. This is false. Because this is false, it means that that is not a solution. So because that is not a solution, we're going to go back to our graph, and we're going to shade the side that does not include that point. That means all of my solutions are found above this dotted line in that shaded region. Moving on to number 6, we already talked about slope-intercept form in the last problem. Remember, slope-intercept form is y equals mx plus b. What we have here is an equation that's in point slope. So we want to take this and we want to get y by itself. So the first thing we're going to do is take care of the parentheses. So we're going to distribute. Notice that there are no parentheses in our slope-intercept form. Making sure we distribute that negative 2/3 to both the x, giving us negative 2/3 x, and to the negative 6, giving us positive 4. From here, we want to get the y by itself, so we need to cancel out this negative 4 by adding 4 to both sides, making sure we only combine like terms. So I'm going to add it here at the end to the positive 4. 4 plus 4 gives me 8. So in slope-intercept form, that equation would be y equals negative 2/3 x plus 8. Number 7, identify each solution to f of x equals 0 by placing points on the graph. So remember that solutions, roots, and zeros are all the same. They're all found in the same place. They're all found on the x-intercept. So we're simply going to go here and put a point wherever this graph crosses the x-axis and nowhere else. So right there at negative 5 and at positive 1. Number 8, we've got the graph of a system of linear equations. Based on the graph, what is the apparent solution? Well, if we have a system of equations, we have two lines that are graphed, and the common point or the intersection point is going to be the solution. So this intersection point is at 4, 3. Remember, the x always goes first, y comes second, so it would be 4, 3. Number 9, find the domain. Domain refers to x values. So on a graph, we're looking at the horizontal axis. So as the graph runs left to right, I'm going to look at the arrow here. The arrow is pointing to the right. We have no arrow pointing to the left, but we got a stopping point. The graph stops here Remember, we're not concerned with up or down. We're only concerned with left to right. So we're only looking at the domain, which is only the x values. So at that point where it stops, there's nothing to the left of that. Everything's to the right. So we have to look and say, what's our x value where it stops? Well, that x value is -3. And because the graph is going to the right, all my x values are getting bigger. -2, -1, 0, 1, 2, 3, and 4 are all bigger than -3. So when I look at my inequality, it would have to be greater than -3. Number 10, find f of 4. This notation is function notation. It's telling you that we're going to use a function f with an x value of 4. So they're giving us the function rule right here. So I'm simply going to take that rule, and wherever I see an x, I'm going to plug in a 4. And then we're going to simplify. Now keep in mind it says the answer must be in the form of a fraction, so we do not want a decimal here. So I'm going to simplify the bottom, which gives me 6. 3 over 6, I'm going to simplify to 1/2. Make sure you follow directions. If the question on the SOL says they want the answer in the form of a fraction, and you put in a decimal, it could be the correct decimal equivalent, but you'd still get the question wrong because you didn't follow the directions. So make sure you read the question carefully and give the answer in the form that they ask for. Number 11, we've got a table of values here, x and y. It wants us to determine whether this is a direct or an inverse variation, and then pick the correct equation. So we're going to look at our values here. You notice that our x values are increasing. I cannot spell apparently. And the y values are also increasing. X values go up and y values go up. If they both go up at the same time, that means that it's a direct variation, not an inverse. So it has to either be A or B. So we've got two equations here, y equals 2/3 x or y equals 3/2 x. Easiest way to do this is to plug our values in and see which one works. Well, if we start with 0, if we plug 0 into this equation, y equals 2/3 times 0. That gives us 0. But the second one does as well. Y equals 3/2 times 0 also gives us 0. Okay, so that doesn't help us. So we need to go back and try another point. So let's pick the point 3, which is x value of 3. So I do y equals 2/3 times 3. I get 2. That checks out. That's what I'm supposed to get. Let's check the other one just in case. Y equals 3/2 times 3. Well, that gives me 4.5. Not what I want to get. So that means that this is not the correct answer, not the correct equation. So my answer choice would be A, because it's a direct variation, and y equals 2/3 x is the correct equation. Number 12, another variation equation. It gives us the pressure of a gas and the volume, and it gives us two scenarios. Pressure is 30 pounds per square inch when the volume is 120 cubic inches. And then the pressure increases to 40 pounds per square inch when the volume decreases to 90 cubic inches. So that relationship right there tells us that it has to be inverse. The pressure is increasing from 30 to 40, and then the volume is decreasing from 120 to 90. So we know it has to be inverse. So I'm going to cross off the direct answers. So once again, we have two inverse answers with two different equations. V equals 4 times P. So we're going to go back in and use the fact that it's multiple choice to our advantage. Plug in, we've got V for volume and P for pressure. So let's plug in 30 pounds of pressure and see which one gives us the right answer. 4 times 30, well, that gives us 120, so that works. Let's try the second one. V times P. So here, I'm going to plug in both. I'm going to multiply them together. So the volume is 120, and the pressure was 30. 120 times 30, well, that equals 3,600. So both of these equations work for the first pair. So let's go check the second pair. B equals 4 times P. So 4 times 40 equals 160. Well, we need it to equal 90, so that doesn't work. Let's check the second one, see if that one works. Volume was 90, pressure was 40. 90 times 40, that equals 3,600. There's our check. There's our equation. So our answer has to be D. Number 13, we have quiz scores for students in first period, second period, and third period history class. The question asks about the variability. So variability refers to the spread of the data. In other words, how spread from the mean or how far out from the mean does this data go? Is everything really close to the mean? Is it really spread out from the mean? What does it look like? So what you want to do here is you want to use your calculator and find the standard deviation for each of these 3 class periods. So once again, really quick, to do this, you simply put the data in at list 1. So I'm going to start with first period. It's all going to go to list 1. And then I'm going to go back to stat. I'm going to go over to calc. And then I'm going to press 1 var stat. So I'm going to pause the video real quick, grab the standard deviation for each one of these. If you have a graphing calculator in front of you, I'd like for you to do the same. If not, something you need to do when you're in class. So here we have our 3 standard deviations. The first period standard deviation was 10.09, the second period was 6.4, and the third period was 7.89. That means that the first period is the most spread out because it has the largest standard deviation. Second period is the least spread out because it has the lowest standard deviation. And third period is somewhere in the middle. So read the question carefully because it says which is not true. So you look at answer choice A, standard deviation for the second period class was about 6.4. Well, we saw that was true. Okay, so we're looking at something that's not true. B, standard deviation for the third period was about 7.9. Well, 7.89, that's true. Okay. Sample from the first period class was the most variable. Well, has the highest standard deviation. That means it's the most variable or the most spread out. Answer choice D, the sample from the third period class was the least variable. The third period does not have the lowest standard deviation. Therefore, it's not the least variable. Second period is the least variable. So the fourth answer choice here is the one that's not true. 14, data collected for a student involving IQ scores of 5-year-old girls produced a mean of 100 and a standard deviation of 15. What is the z-score associated with an IQ of 112? So remember, the z-score formula is the observation minus the mean divided by the standard deviation. So here we have the mean, we have the standard deviation of 15, and we have an IQ of 112. That's our observation. So we're going to do 112 minus 100 divided by 15. It gives us 12 divided by 15, which gives us a z-score of 0.8. It's a simple equation, making sure you plug everything into the correct place, and then simplify it. Number 15. Graph below shows the number of movies that Netflix had in its library over the first 10 months of its existence. Which of the following functions represents the relationship between months open and total movies? So we've got 4 functions here. We want to figure out which one represents this line. So looking here, I'm looking at the functions. Each of these is in y equals mx plus b form. So we want to figure out what's the y-intercept and what's our slope. Let's start with the y-intercept right here where the point crosses the y-axis is our y-intercept. Crosses at 4,000. So we need an intercept of 4,000. All of the last 3 have that. The first one does not. So I'm going to cross that one off. Next, we want to look at the slope. So we need to look at the rise over the run. How far up and over does this go? So it goes up 1, 2, 3, 4. Now this is in thousands, so it actually goes up 4,000. And then it goes over 8. 1 over 2, 8. This point right here is at 8 months open. So it has a rise of 4,000 and a run of 8 days. So 4,000 divided by 8 gives us 500. So our slope should be 500, so that would be answer choice C. That wraps it up for this SOL prep. As always, go back and review anything you need to. If you do have questions, make sure you get those answered in class.